Hydraulic Machinery Division. The Hydraulic Machinery and Cavitation Division of CWPRS, established under UNDP during the year 1984, is catering to the services of testing pumps, turbines, and calibration of flow meters. The gravimetric and volumetric laboratories undertake calibration of flow meters and testing of filters and other flow elements. Extensive experimental and research studies related to hydraulic machines and flow measurement in specialized areas undertaken in this division are field investigations for flow measurement by secondary calibration method, field studies to assess hydroturbine performance for hydropower plants, surge analysis of lift irrigation schemes, model studies for evaluation of hydraulic performance of pump intakes, desk studies for development of hydraulic designs of pumping systems. Calibration laboratory services. Calibration of flow meters and water meters is essential for custody transfer of water, interstate sharing of water, and flow through hydroturbines in hydropower sector, drinking water distribution systems, etc. Filters and strainers are used to filter out the suspended particles in water to supply clean water for drinking water supply schemes and applications like steam generation in thermal power plants, and are required to be tested for the pressure drop which defines their effectiveness. Valves usually used to control the flow rate in any flow process system are required to be tested to ascertain their head loss, discharge characteristics, gravimetric and volumetric calibration facilities conforming to ISO 4185-1993, ISO 8316-1993 are available at CWPRS for calibration of flow meters, testing of filters, and ascertaining valve characteristics. Volumetric calibration facility. Maximum line size 250 mm, integrated with submersible pump test rig. Maximum flow rate 0.083 cubic meters per second. Calibration uncertainty plus minus 0.5%. Capacity of volumetric tank 3.862 cubic meters. Gravimetric calibration facility. Maximum line size 1000 mm, extendable up to 1200 mm. Maximum flow rate 2.0 cubic meters per second. Calibration uncertainty plus minus 0.3%. Weighing tank capacity 100 tons. This facility is so far the largest in the country. Pressure drop test and design optimization of heavy-duty water filters of thermal power projects of NTPC, BHEL, L&T helped boost infrastructural capabilities of the nation for energy generation needs. Testing of filters and calibration of flow meters performed for clientele like Gujarat Autofilt, Autoclin, Jaish Engineering Company, ONGC, MIDC, Kirloskar Brothers Limited, Niho Koso Japan, SBEM, Filtration Engineers, Shivalik Engineering, Nivo Controls, Manas Microsystems, Aquamias Instruments. Performance testing of submersible pumps. Effective utilization of groundwater is possible with performance evaluation of the submersible pumps. This hydraulic machine is one of the important disciplines which is concerned with studies of rotordynamic pumps and pumping systems. Submersible pump sets are tested as per testing procedure described in IS 9283-2013, 8034-2002 and also 9137-1998. During the last 30 years, CWPRS has provided practical solutions to various projects in the field of rotordynamic pumps. The state governments of Rajasthan, Bihar, Karnataka, etc. had benefited from hydraulic performance and overload tests on submersible pump sets of different flow and head capacity. In recent times, pump sets of various capacities for irrigation department of Uttar Pradesh, Lucknow, were extensively studied. It is a standard practice to get a sample pump set tested during bulk purchase for bore wells. Field investigations for flow measurement. The measurement of flow rate is very significant for effective utilization of available water resources. It is important to properly determine what type of metering technology is best suited for custody transfer or process control applications. Many industries are looking forward to streamline the water consumption pattern through water auditing in view of scarcity of water resources. Site calibrations of flow metering systems are performed by secondary calibration methods in order to suggest technical guidance for proper flow measuring installations at site and to improve the existing water drawal system for better usage of water. Hence, many agencies like Tata Power, NTPS Nashik, Usha Martin, Hindalco are some of the beneficiaries of this exercise. Field studies for assessing hydroturbine efficiency for hydropower plants. Performance evaluation of hydraulic turbines undertaken through field studies comprise of measurements of flow for different reservoir level, net head on turbine and power input. Evaluation of overall efficiency of a turbine plant is an important factor during normal operation of an existing plant or renovation, modernization and upgradation works. Turbine efficiency plays a vital role during acceptance test of a new turbine unit. Surge analysis. Water hammer occurs whenever the fluid velocity in pipe systems suddenly changes, such as at pump stop, pump startup, or valve opening and closure. It is important to design pumping systems to prevent water hammer in order to avoid potentially devastating consequences, such as damage to components and equipment and risks to personnel. CWPRS has a special purpose software WH2.7 developed by Dr. Hanif Chaudhari to offer solution based on method of characteristics. Based on transient studies, anti-surge devices such as air chamber, air valve, zero velocity valve, etc. are recommended to mitigate water hammer for safe operation in the long run. Many NTPC projects, state government agencies and other public health engineering departments are beneficiaries of this work. Hydraulic model model studies for pump intake systems. Most of the cooling water intakes in thermal power stations, drinking water systems, irrigation schemes, etc. involve multiple intakes fitted to a sump that caters water for specific purposes. In order to obtain satisfactory performance of pump intake systems, physical model studies are conducted. A number of studies of pump-sump design have been undertaken at CWPRS. These include Bhopal City Drinking Water Supply Scheme, Natpa Jhagri, Tarapur and Madras Atomic Power Station, and to various super thermal projects like Kota, Parali, Singrauli, Tuticorin, Talcher, Unchahar, Farakka, Ramagundam, Kathalguri and Tripoli West Thermal Power Station, Libya, Port Klang Thermal Power Station, Malaysia, Kuttiyadi Power Intake Studies to evolve vortex swirl-free flow conditions, safe and economical designs of pump intakes. The model study for Love Grove Sewage Pumping Station at Worli, Mumbai was a special study, considering the limited space at the site. Vertical expansion of the sewage filtering was recommended that suited a city like Mumbai. Desk studies for economic pump-sump pipeline optimization were also carried out for Damodar Valley Corporation, NEEPCO, Gomti River, Indore and Bhopal City Drinking Water Supply Scheme, and Bonal Lift Irrigation Scheme for KBJNL, Narayanpur in Karnataka State. Under HMC division, CWPRS has been conducting various training courses and national workshops related to flow measurement, pipeline optimization, transient analysis, pumping systems and operation of turbine plants. Services at HMC division. Calibration and testing services. Calibration of closed conduit flow meters and water meters. Assessment of pressure drop across heavy-duty water filters. Assessment of flow coefficient of hydraulic valves. Hydraulic performance testing of submersible pumps. Field studies. Performance evaluation of hydroelectric power plants. Upgrading of existing hydro power plants. Site performance of flow meters and proper layout for water pumping system. Standard installation of appropriate flow measuring devices. Pumping system optimization. Surge analysis of lift irrigation schemes. Pump-sump model studies for improvement.